So the wheat industry in South Africa funds me to do all the testing of commercial varieties as well as advanced breeding lines for all the breeding companies. I'm not a breeder myself, so they like the fact that I'm neutral and they can send it to me and I will do an unbiased screen in the greenhouse, do multi-pathotype testing with all 3 rusts, and I also do a field assessment. And this picture comes from our winter wheats from the Small Grain Institute breeding program. 2 different winter wheat lines tested with TTKSF, and the same lines tested with TTKSF plus, the UG99 variant with virulence for SR9H. So now I can tell the breeders those 2 lines have a vulnerable gene. In case you release a variety from that particular source, you may have problems in future. So immediately they have a sense of the risk involved. I also test, as far as possible, new sources of resistance. These stems are from adult plants tested in the greenhouse with a UG99 PTKST, and the source is a stem rust resistant source which I obtained from Dr. Ian Dundas from the University of Adelaide. It's an unnamed gene at this point. It comes from Agelop speltoides, but immediately you can see it's highly effective under extreme or a very strong inoculum pressure. In the background, you can see some of the susceptible checks for other materials tested in that same cycle. So we can test commercial varieties, we can test new sources of resistance, and obtain valuable information. When we move to the field, and this is my program done in collaboration with other people. We developed a double haploid population for stripe rust resistance where we combined 6 QTL for stripe rust resistance and also SR2 and LR34/YR18. And then we genotype these so we know which line contains which gene or then chromosome region. So if we didn't have the particular isolates or the pathotypes, it would not have been possible for us to accurately assess the response of these genes individually or in different combinations. So we can now tell the breeders it's probably better to use, say for instance, gene A, B, C, and D rather than X, Y, and Z. But an important point, and I'd just like to share this picture with you. I tested this population in the field last year, and this particular line had all the genes listed there except the 4A QTL, which is a slow rusting gene, or QTL for stripe rust. You can look at the amount of necrosis on that particular line. Now at this point I cannot say whether it was due to rust. We'll have to repeat and do more specific tests, or whether it's just linkage drag, or whether it's just a combination of undesirable genes that combine in this particular entry. But whenever you read a paper or a textbook on rust, you read the words, you see the words pyramiding, stacking, combination. And the point I'd like to make at this point is by just blindly stacking genes for resistance, it's not to say that you will get a highly productive variety. So there's still a lot for us to learn by adding or combining specific sources of resistance into one genotype. But again, getting back to the topic, none of this would have been possible if we didn't have the cultures to work with. And we used the most virulent culture. I mean, the question's been asked, what culture do you use? We use the most virulent culture. That's the most dominant one in our country to infect this particular nursery, so we can see what works and what does not work. And we then also could test in the field our winter wheats. They're often difficult to test for us in South Africa because the environments in which they are commercially produced, it's cold and it's a difficult environment to get good stem rust growing. So in my nursery, I can now actually get good information and tell the breeders which of their specific entries are resistant or which are susceptible, and they can then decide how to proceed with that, with their breeding material.